Assalamualaikum. Hello viewers. Today I am going to discuss with you some problems from differentiation. Here, first we have to differentiate this expression. If we compare this expression, we can see that this is in UV form. So formula of differentiating an UV expression, we have to differentiate plus v term, then uh, u term. When we differentiate v term, then u will be out, and when we differentiate u, then v will be outside of the term. So here if we suppose that this is a v, this is u and this is b, then first we have to differentiate this term, then we have to differentiate this term. When we differentiate this, that will be 6 this term, and 5 to the 6 minus 1. We know that if we differentiate x to the power n, it becomes n x n to the power minus 1, like this. This will be 6, this expression, this we considered this full expression as x, 6x 6 to the power minus 1, that is 5. And when we differentiate this, again we have to differentiate this x term, which is 10x. Okay. And same things we have to do for this term also. First we have to differentiate this term, we have to consider this as x, then 5x to the power 5 minus 1, and again we have to differentiate this term 2ax, and from which we get 2a only. Now from this two expression we can take common 2a x plus 5 to the power 4 this term, and 5x square minus ab to the power 5 this term, and our remaining part will be this. And then we have to do a little calculation here, algebra. We have to multiply and then addition, and finally we get the required our required expression after differentiating the given expression. Okay. Now for the second problem, this problem, notice here, it is in u by v form, which is the formula is u by v. When we differentiate any expression which is u by v form, first the formula is v square, and in the denominator and in numerator, first we have to differentiate u minus, then we have to differentiate v, right? So if it is u, then and v, we compare this with this u by v, then v square and v will be outside, v d by dx u, then u d by dx v. Okay. So when we differentiate this term root over x, we know that it will be the square root of x, it means x to the power half, right? So when we differentiate this, half will be come at the first, then power will be half minus 1. So which is happening here, half to the power half minus 1, and this term will be, when we differentiate the x plus 1 root over x plus 1, and it becomes half x plus 1 to the power half minus 1. So this becomes half minus 1, which is minus half, and we can write this through like this way. Now we have to do a little algebra, and we have to bring this to in the denominator, and after calculation, and we get our final result, which is this expression. Okay. So I have I have shown you two problems. First problem was a UV formula, which is multiplication when the two expression in multiplication form, and this is the division form. Okay. Now another uh, problem which is in UV form. Similarly, we have to do first the v, I mean the second expression, then first expression will be outside, and then first expression and second expression will be outside of the differentiating term. Then finally after differentiating and taking common and doing calculation, we get our result here. Now we are going to discuss you some difficult problems, critical problems. Here we are given is if x square by sin a is equal to xy, then we have to find the dy by dx, right? So our given expression is x square by sin y is equal to xy. So first we have to change the we have to change it, and from which we get x square is equal to xy sin y. Now differentiating both sides, we get x 2x here, and in the right hand side we get here there are three terms here, right? X, y, and sin y. First we have to differentiate y, then we have to differentiate x, and we have to differentiate y, right? So here first we differentiate y, then we differentiate x, then we differentiate the y. We can say that this is a UBW formula, right? First we differentiate w, then we differentiate v, then we differentiate u. So finally we get the dy by dx. We just differentiate, then we take common dy by dx, and the remaining part we bring it to in brackets, and then we find the value of dy by dx, which is this expression, right? Now here is another problem. We have to find the coordinates of the points on the curve x square minus y square is equal to 3xy minus 39, at which the tangents are first problem is parallel to the line, and then perpendicular to the line. Okay, so given coordinates of the given curve, equation of the curve is this. We name it equation 1, then we differentiate both sides. After that we get dy by dx. Value of dy by dx is 2x minus 3y divided by 3x plus 2y, and our given another line which is x plus y is equal to 1. From that we get y is equal to minus x plus 1, and the slope of this line will be minus 1. How we get this? From the formula, you know, y is equal to mf plus. If we compare this equation with this formula, we get the value of m, which is minus 1. This is the slope, and now we are being say told that the tangent is parallel, then the slope is equal to the straight line. We are given that the tangent will be parallel to the line. So if the tangent is parallel to the line, the slope is equal to the straight line. That means that this slope 2x minus 3y divided by 3x plus 2y is equal to minus 1, and from this by calculation and changing side we get y is equal to 5x. And again this y is equal to 5x, we substitute from 2 in equation 1, we get the value of x are plus minus 1, and from these values of x we get the value of y, which is plus minus 5, and the points are 1 5 and minus 1 minus 5. Again similarly, if the tangent is perpendicular, then the slope of the product will be minus 1, which is the slope we found 2x minus 3y divided by 2y plus thrice x times minus 1 is equal to minus 1, and from this we get x is equal to minus 5y, which is equation 3. So substituting the value of x in equation 1, we get 25y square minus y square is equal to minus 15y square minus 39, and from this we get the value of y square is minus 1. So since the value of y square is minus 1, so there will be no real value for y, right? And similarly no real value we will not get from x for x, right? Since the value of y will not be real, so value of y x will also not be real, right? So no point exists where tangent is perpendicular to x plus y is equal to 1. Then now we are going from another more problems. Here we are given that if y cos x is equal to 1 plus sin x, then we have to find the dy by dx in terms of x, right? So given expression is y cos x is equal to 1 plus sin x, then from this we get y value of y is 1 by cos x plus sin x by cos x, which is sec x plus 10x, and if we find the dy by dx, then sec x will be sec x 10x. You know that the formula of when if we differentiate sec x, we get sec x 10x, right? And similarly, if we differentiate 10x, we get sec square x. And if we take common sec x outside of the bracket, then we get 10x here, and here we get the sec x only, right? And again we transform it 1 by cos x, sin x by cos x, 1 by cos x, and by cancelling cos x, and remaining 1 plus sin x divided by sorry, no, we don't cancel cos x here, we just multiply here 1 plus cos x divided by cos square x, right? Now here for the last problem, we are given that x to the power a and y to the power b is equal to c, where a, b, c are constants. Then we have to prove this, right? And from the given expression, we differentiating both sides, we get x to the power a, and this term will be by to the power b minus 1, and again we differentiate y dy by dx. And similarly, this is in uv form, right? First we have to differentiate v, then we have to differentiate u. Okay, so first we have to differentiate this term, plus again we have to differentiate this term, right? So first we differentiate y to the power b, then y to plus y to the power b, again we differentiate x to the power a, which is a x to the power a minus 1. Now it becomes b x to the power a y b to the power minus 1 dy by dx, and equal to minus y to the power b a x to the power a minus 1. And from this we find the value of dy by dx, which is minus y to the power b a x to the power minus 1 times 1 by b x to the power a times y to the power b minus 1. And cancelling, it becomes here, notice here the a x to the power a minus 1, it becomes x to the power a divided by x, right? Here a power of x is 1 here, so it becomes x to the power a minus 1. And similarly, y to the power b minus 1, this y will be, we can bring it to numerator, and again after cancelling the terms x to the power a and y to the power b, we get our required expression, which is a minus ay divided by xb. This we are being asked to prove. So these are the problems I tried to explain you. I hope differentiation will be easy for you if you see the today's video here. And please tell me which topics are seems you find difficult. If you tell me about your topics and problems, I will try to bring this that solution for your problems in the next video, and making things easy for you. Hope this video will help you in your study, and subscribe my channel. Please support me. Hope you all the best. Thank you everyone.